Hi everyone, my name is Henry Ho here. Welcome to Anomaly Detections in Y activities. So a global international bank was searching for new and innovative techniques for detecting anomalies in their wire transfers. So the goal was to have easy to execute detection rules that were customized specially for each groups of their customers. So the problem statement was, provided with the unlabeled data, how could machine learning be trained with this data? So it could detect anomalies in any new data that it has never seen before. So the model identified and selected was the ensemble of isolation forest and local outlier factor. And here were the sample dataset size and temporal. So for the period between January and December of 2020, for a total of 3 continents, Asia, Europe, and North America, for a total of 132 countries, and for a total of 139 customers, and for a total of 4 million transactions. And here is the pictorial of the proportions of the transactions belonging to these 3 continents. And as one could see here on this pie chart, that the continent of North America had the largest number of transactions. And as for the metadata, the sample data set had a total of 7 nominal independent variables, 1 currency, 1 datetime, and 1 ordinal. And here were the 6 detection rules that we built along with their threshold settings. For example, for Asia and for message type MT103, if an outlier transaction amount that was larger than 113,000, then it was flagged as suspicious. So the same logic was applied to the rest of the rules here on this table. And here is the rule building concept. So for example, for the continent of Asia, the rule was broken into 2 groups. And the reasons for that, as one could see here on these 2 plots, that the 2 groups do not exhibit the same pattern. Therefore, different thresholds should be set for each of these 2 groups. Also on these 2 plots, as one could see that the monthly median transaction amounts were calculated. The reason for that was because they could be used as the baseline for determining whether the outlier transaction amounts were good outliers, meaning if the outlier amount was smaller than the monthly maximum median transaction amount for the group, then it was not good for threshold setting, because normally criminals will not bother with small transaction amounts near or below the baseline. So this same concept was applied to the rest of the rules for the other 2 continents, the continent of Europe and the continent of North America. And here is the interpretation for the unsupervised machine learning. So on this table here, as one could see, that the average of the total input transaction count was about 623,000. And the machine learning was able to detect about 4,000 anomalies. So what that meant was that on an average, the machine learning was able to detect about 0.67% of anomalies. So this is the interpretation for the unsupervised machine learning. And here is the interpretation for the supervised machine learning. So here, as one could see, the 6 confusion matrices. And as we all know that in fraud detection analysis, we are only concerning about the recall and precision of class 1. The number that we are most concerning about is the number of false negatives. It is because an overlooked case of fraud could result in the financial institution of receiving hefty fines from the regulators, and at the same time, its reputation could be damaged by the scandal. So the goal here is to have 0 false negatives. And as one could see that each of these matrices capture the detection accuracy for one input dataset. And each of these datasets was created to set the threshold of one single rule. And from examining the numbers on these matrices, one could see that the numbers of false negatives are very small if compared to the number of true positives, meaning that the sensitivity percentages are very large. And if one looked closely, one could see that the number of false positives are very large. So, meaning that the specificity percentages are very small. And if one looks at the corresponding accuracy statistics, one will see that the majority of the recalls are very large, meaning that the sensitivity percentages are very large. And this is a direct reflection of the numbers on the confusion matrices. And again, if one look closely at the 6 tables here, one could see that the precisions are very small for class 1, meaning that the specificity percentages are very small. So again, it's the direct reflection of the numbers on the confusion matrices. So these are the results for the predictive accuracy of the supervised machine learning. And here is the model evaluations and selection. As one could see from the accuracy statistics from the previous slide, that we could not select the supervised machine learning for threshold setting because the predictive accuracy for the model was not good enough for threshold setting. And that was the reason why we selected the unsupervised machine learning for threshold setting. And as one could see on this table here, that the most important column from the unsupervised machine learning is the minimum outlier transaction amount. As one could see that none of these amounts was smaller than the median transaction amount, which meant that the machine learning was working correctly. Since all the outliers detected by the machine learning were good outliers, they could be used for threshold setting. Also, if one looks on the far right on this table, the maximum outlier transaction amounts match with the actual maximum transaction amounts. So these were the results for the model evaluations and selection. And as for the suggestions for our subsequent analysis, the full potential of supervised machine learning has not been explored for this research. There are many more combinations of hyperparameter values that the researcher could have tried. There are many more combinations of base models for the ensemble learner that the researcher could have tried. Each of these trials took a substantial amount of time. So more time should be allocated for supervised machine learning in the next iteration of this research. And as a conclusion, we were able to achieve an average anomaly detection rate of about 0.67% on all the 6 detection rules. And the highest sensitivity percentage we were able to achieve for the supervised machine learning was 99.9%. However, the highest specificity percentage we were able to achieve for the supervised machine learning was only 55%. And that was not good enough to be used for threshold setting. So more iterations of cross-validation are needed to find the most robust set of hyperparameter values. So the next iterations of this research, the researcher should continue on the same journey of finding this most robust set of hyperparameter values. And the last slides here are the references for the entire research. So thank you everyone for attending these presentations. You have my email and my phone number. You could always reach out to me for any question. So once again, thank you for attending this presentation. Bye now.